Thank you very much. Through the day yesterday, it's very easy to start to feel very depressed of every additional challenge that we face in producing research literature that we can feel confident in, that we're making progress in and otherwise. But it's in those moments of watching all those presentations yesterday where I start to feel more and more excitement. And it's not because of the challenges exist, it's that we know now that the challenges exist. They would exist whether we were studying them or not. So what's super exciting about meetings like this is the researchers that are actively starting to investigate these problems, and even more importantly, the presence and collaboration of stakeholders, funders, the publishers, the editors that say, this is an issue, we can do something about this. Let's experiment, let's try some new things, let's evaluate some interventions. So I really feel like over the last 10 years, because of the work that all of you are doing, we are in a renaissance for actually starting to improve in meaningful ways how peer review is done and how we make progress in scholarship more generally. So thank you very much for the work that you're doing. I just feel a lot of gratitude coming to meetings like this. What I want to talk about is a couple particular examples extending on some of the things that Paul Glasziou said at the end of the day yesterday, where he was talking about a theory of change that we use to drive our organizational practice, and a lot of others are employing in different ways, of how is it that we can actually institute change and get it to stick in ways that align the values and ideals we have for science with the daily practice of what happens. And the part that I want to focus in on, given the context that we're in here, is publication as the currency of advancement, and the challenge that that creates for the incentives for researchers and the reward structures that end up sustaining and expanding many of the challenges that we are collectively investigating. And we know that because publication is the currency of advancement, and that only some things get published, or some things are more likely to get published than others, more likely to get published finding a positive result than a negative result, more likely to get published finding a novel result than something that someone else has done, more likely to get published if you have a neat and tidy story than mess, exceptions, things that don't quite work. That we've created a reward system that is focused on outcomes, and those outcomes then drive researchers' next steps and what they are able to achieve and how they advance. So none of the changes that we're trying to make, none of the improvements we're going to try to make are going to stick unless we address and tackle directly that reward system itself. And that might mean in part expanding what people are rewarded for beyond the publication, but it might also mean that we need to change how it is decisions are made about publications to be more productive in advancing the kinds of research that we want to. So that's the part that I want to focus on in providing some evidence of one of those interventions that really goes after not changing what's rewarded, publication, but changing how a decision is made for what gets published in ways that much more closely align with what we had idealized scientists focus on. So in the model is registered reports, and this may be familiar to some, but I'll give the cartoon description of it. This is the research process. You design a study, you collect and analyze the data, you write the report, and you try to publish it. But of course, in the standard model, the barrier of peer review happens after the report is written, prior to its publication. And the key change of registered reports is to move the initial stage of peer review to just after the design phase. So as an author, I do my exploratory work, I come up with an interesting question, I think I've got a handle on a phenomenon, and what I submit to the journal is, here's my question, here's my rationale why this is important, here's some preliminary data to suggest my methodology is on the right track, and here's my proposed method for how it is I'm going to test that question. And what the reviewers evaluate is that an important question? And do you have a rigorous methodology to test that question? And if it passes those criteria, the journal makes an in-principle commitment to publish the results regardless of outcome, as long as you follow through with the work as you said you would in the paper. Just this change fundamentally alters the reward structure for me as an author. In the standard system, it's all on the outcomes. I have to get novel, positive, exciting outcomes if I want to maximize my chances for publication. In the registered reports model, it's all on questions and quality of methodology. No one knows the outcomes, so they cannot influence the publication decision. And so if I get that in principle acceptance, then what changes for me as an author is I'm no longer pressured to get certain kinds of results. My goal is to do the best darn study I can with the methodology I said I was going to do. So if this works, what it should do is eliminate publication bias, and it should increase rigor of the research itself because we're actually rewarding on rigor. It's about the methodology that gets evaluated. And the initial data of registered reports that have been adopted, now 300 journals are using registered reports as a publishing option. This is one study of some of the early registered reports where they compared registered reports with matched controls in the same journals on whether the first hypothesis in the paper was supported. And what you see on the left is 95% of the standard reports found evidence for their hypothesis. Wow, they're right every time. Why even bother doing the research if we know we're going to be right every time? With registered reports, when the publication decision was not based on the outcomes, only 40% of the hypotheses were supported. That itself is eliminating, ideally, if registered reports are implemented right, publication bias entirely. On the second part of rigor, we took the 27, I believe, registered reports and then matched controls of papers done in the standard way by the same authors and a second set of controls and on the same topic published in the same journals. And we put them through a structured peer review process again, where 353 reviewers were randomly assigned pairs of papers to review on a variety of quantitative and then open-ended criteria. And what you're seeing here is the comparison of the evaluation of the registered report versus its matched controls on a variety of different criteria. And it's hard to see from where you are, but on the top are the criteria that were evaluated before they knew the outcomes. So we gave them the papers incrementally. They got to see the introduction and methods and the initial studies, and then they wrote some about, and then the design of the critical experiments, they wrote an evaluation. Then they got to see the experimental outcomes and the discussion of that in blue. And then they got to see the whole paper and evaluated in green. Everything to the right of the dotted line indicates that the registered reports perform better on average than the standard papers. And on every criterion, methods, rigor, quality of methods, the amount we'll learn, the novelty of the question, the creativity of the methods, registered reports perform better from a little to a lot. Those are Bayesian credible intervals, if you're wondering on the data. And that occurred across every different criterion. Now, this is one study. We need to keep doing this as registered reports expands. But what it suggests is that on all of the criteria we care about, at least in this particular design, we see that registered reports don't provide anything negative. If anything, they provide a positive in improving rigor of the approach. So once we start to innovate on thinking about different ways on different occasions, when do we provide evaluation? We can also start to think about how do we align the different stakeholders in the community that are reward system drivers for authors. The registered report model is perfectly placed to match up journals and funders into a singular process where the authors submit their proposal with a budget for what research they're going to do to a single review process, where the journals, if it passes review, commit to publishing it, and the funders, if it passes review, commit to funding it. Everyone in this situation loves this because the journals get high quality research to their journal. The funders get essentially a guarantee that the things that they fund will eventually get out. So many funders are frustrated by the amount of waste of research that they fund where none of it is ever reported anywhere. And authors say, I go through a single review process and I get the money and the paper, sign me up. So we have funding from NSF to evaluate these interventions and their impact on different sub-communities of research where different funders have committed to doing this work in partnership with journals within their fields to see if it actually affects culture change. So not only may it reduce the bias in the actual research output, but by getting multiple stakeholders involved in a process that emphasizes rigor, they can affect the community around them of creating new norms, of signaling that this is something that's important for the field and that we're going to change. So one example of that is this call that we have active right now in consciousness research. This is from the Templeton World Charity Foundation is the funder for this, and we have a number of journal and society partners that publish research in consciousness. And essentially our role organizationally as the charity is to just help administer the process for managing the workflows of getting these awards and integrating between these systems. And otherwise, the funders and the journals just do their work as they do their work. So any community that's interested in trying these as pilots or experiments, please do follow up, because they've already had a substantial impact in some subdisciplines. So I want to leave that registered reports aside and talk about another area of work that is really much more horizon work for us now that could complement the kinds of things that are done to change the incentives for authors as they're doing their work, and more focus on the evaluation side. And this is a project that has just concluded data collection, a DARPA-funded work called the SCORE program. And there are many different teams that have been involved in conducting this program. And in fact, it's involved the work of about 2,000 researchers involved in different ways for this project. And the work is interested in seeing if we can generate automatic ways of evaluating the confidence that we should have in research claims. So the simplistic form is each paper gets a score. This one's a 94, this one's a 26. And the algorithms then may provoke attention to areas that the machines think are areas of weakness or uncertainty, that then humans and other mechanisms that we have for evaluating confidence in claims can then follow up and pursue more evidence for that. This work what got initial investment by some evidence from us and others that humans and machines can predict the replicability of research, of findings in research. So we run these very large replication projects in different subfields. And alongside the projects conducting replications of published findings have been prediction markets where people bet money on whether they think the finding will replicate or not. Surveys conducted where they just have people guess whether the likelihood that papers will replicate. And then algorithms that are trying to make those same predictions based on some earlier training data of replication studies to see if then they could anticipate new replication outcomes. And what you're seeing here is the aggregate results across multiple investigations with prediction markets, surveys, and algorithms, where higher values on the y-axis are predictions of replication success and lower values predictions of replication failure. And then the solid dots are the actual replication outcomes. A successful outcome on the simplistic criterion of was the effect in the same direction and statistically significant are solid. And then the open circles are failed replications on that criterion. And in all of these cases, people can predict with markets or surveys, and the algorithms perform as well or even better in some cases. And so the SCORE program took this to the next level of investment and tried to create a new data set and multiple algorithms to try to anticipate replication success. So this is the very simplistic description of the study. We took a stratified random sample of 10 years of the social behavioral science literature across 62 different journals. We extracted claims from 3,900 papers from that random sample and gave those claims to human teams, the Replicats Project and KeyW, that had different approaches for humans evaluating confidence in those claims, and then 4 machine teams. They generated scores for those 3,900 papers, and we, in the background, selected a subset of those papers that they didn't know what were selected for replication reproduction studies. And then we ran all of those studies, collecting lots and lots of ground truth evidence of are these findings reproducible and replicable, to compare against what the humans and the machines ultimately predicted based on their own training data and otherwise. The outcomes of this are the machine teams came up with a variety of very distinct strategies for how it is they generate and then provide explainability for the scores that they produce for these various claims. And this is just one illustration from the team from USC of how it is they're giving information about where this particular claim scored in their mechanisms for evaluating confidence. So what's happening next in this work is preparation of the reports of the actual findings of that. We do see that the machines are able to anticipate, like the prior work, likelihood of replication. It looks like at about the same level of confidence as the human raters are able to do. But what we need to do next, and half an hour ago, I got confirmation that Robert Wood Johnson Foundation is funding these next steps. So that's good news. But the next steps, thank you to Robert Wood Johnson Foundation, very good. We are now moving from the fundamental research, just establishing proof of concept that this is possible, and working towards research and development to see if this is actually conceivable to translate into useful applications. So one next step is to actually test those prototypes in the wild. And we'll do this with preprint services. We host on the OSF a number of preprint services where researchers will be able to just have an option. Do you want to have your paper evaluated by the algorithms and give us feedback on what you think about that? So that'll be one just to get user feedback in reaction to what these scores are producing. A second is that we now have some support to start to extend into health research. This was focused in social behavioral sciences, so we'll be able to do more in extending the potential generalizability of those algorithms. And then the third step is actually, instead of just 4 teams doing algorithms, is converting this to an open competition where any algorithm team that wants to submit ways of trying to improve prediction of replication success will be able to participate. And then the last I want to focus in on a little bit, which is how do we envision responsible use of such scores? Because there's many ways that such things could go wrong. And a particularly challenging element of AI that is no surprise to anyone is the ability it has to produce and reproduce biases that exist in the data sources it uses. Of course, one focus is on random error. How do we improve the accuracy for predicting replication outcomes, for example, as best we can? But a more pernicious one is the disparate impact that can happen. For example, the algorithms, to the extent that they draw on citation networks as evidence for confidence in a claim, will inevitably reproduce gender biases in citations. And as a consequence, will say, oh, that name looks like it's a female's name. I have lower confidence now in that claim. So that kind of disparate impact, even if we have relatively high precision, would have pernicious and long-standing implications for how it is such algorithms get used. But this kind of work actually provides an opportunity to try to identify those biases because they're already occurring in human judgment, human decisions about citation networks. The algorithms provide a mechanism for identifying those potential biases early because they're drawing on the prior work and to how it is that can be applied in the future, and giving us a chance to now, with multiple different algorithms drawing on different sources of information, of identifying exactly where it is that those biases are occurring and developing interventions to target the areas, the sources of bias, rather than just commenting a concern on the biases themselves. So there's a lot happening, and I'm so grateful to be part of this community, and we love all of the work that's been happening and it's being reported here and elsewhere. The real strength, I think, of the community is in the collaboration, the breaking of silos across disciplinary boundaries, and these collective action efforts between researchers and different stakeholders, funders, publishers, editors, and institutions, to really try experimentation on what is it that can work, what is it that will work, and how do we scale up those things that are working. So this is just to close with an invitation of any of the things that we do that I mentioned here or otherwise that are of interest to you to try out within your context, to collaborate as a researcher. Please do not hesitate to reach out and engage us, because that's where we'll make the most progress. So thanks very much for your time and attention.
Wonderful work and presentation. Thank you, Brian. We have about 5 minutes for questions. Wolfgang from the front.
Thank you very much. Wolfgang Kersendorf, AI and Astrophysics, Michigan State University. Wonderful new tools that you're sort of presenting. And so specifically on the ethics questions for the machine learning, I think one of the things that the tech industry has done really well is open sourced problems. So this is as transparent for all the community as it is. So my question to you is, both registers report as well as this new machine learning technique, is this fully open source? Can people like try it out and like, actually maybe potentially contribute back?
Yeah, excellent question. So the Center for Open Science is a open source only organization. So what we do is build public goods infrastructure. We're happy for commercialization to be built on top of that. But for the algorithms in particular, the model that we are pursuing is very similar to some others, where the base algorithms and scores will be all open source. And then if people want to build closed source solutions on how they pull from those data, that's fine. But also we hope that others will produce open ones. So that's a key part of not only value for that being as public goods, but also we think for the inevitable arms race that will occur between the algorithms trying to assess confidence and others trying to beat that confidence and misuse it, misapply it, game it for other things. So we think that an open solution of a community of researchers working on how do we maximize the quality of those algorithms will be the best way to continue to optimize those against misuse. And eventually, the ideal in any good environment is you make the activity of trying to fool the systems harder than just doing it right in the first place. And if that works, then everybody aligns to the value approach. So
yeah, I mean, we present and we will present later. We have exactly the same spirit, and we think
Awesome.
This is a great way forward. Thank you so much.
Great.
Thank you. Eric in the back.
Thanks. Very interesting. Getting back to the very first part of the presentation. Certainly, journals do often, not often, but occasionally review protocols before studies are done, and which is great because it allows us to tell whether or not the question is interesting and whether or not the protocol will answer the question. And oftentimes we can say, this is something we're really interested in. But a lot of the review process occurs at the end because the question is, did they actually execute on that? On their plans in an appropriate way? Did they analyze the outcomes correctly? And we've heard about spin. Did they fairly present their findings? So I think it's great to have review at the beginning, but there's a lot of review at the end after you see something. So I wonder how much time it saves.
Yeah, excellent point to raise. Thank you for that. So I skimmed over the particulars of the process. It's a two-stage review process. So stage one is prior to knowing the outcomes, where it's on the methodology and the question, and you get in principle commitment to accept. Stage two, after you submit the outcomes, is to address a lot of the things that you describe, right? Did they actually do what they said they were going to do? Did they report it appropriately, and did they interpret it responsibly? What it is not, and this is the key part of that second stage of review, is an outcomes-based review. So the reviewers are not allowed to say, well, I don't like the outcome, so therefore we should reject it. Or I disagree with the methodology now that I see the results, and so we should reject it because of errors in the methodology. Tough luck. You committed to that methodology in the first place. So that's a key part of the distinction of getting that initial commitment and what the review is after. So that's a great issue to raise. Thank you for that.
Thanks. We are at time, so I think we're going to extend it for 2 more questions or so. Theo, is there anybody online with
Yes,
questions?
we have a few, and one echoed what Eric just asked. One is from Stephen Gallo. Do you think any of these methods are applicable to grant review? Should proposals be registered?
Yes, great question. So the middle example that I gave of partnerships between funders and journals is a great way to join up the grant review process with the registered report process. that is a limited case for different types of grant applications, where grants may propose a whole line of research that may cover multiple years, with the understanding in the grant review process that that's going to change. You do the first experiment, you're like, oh, okay, that was wrong. We're going to go this direction, that direction. And that still should be supported and sustained in ways that allow for exploration and following the research where it goes. So I don't think the registered report model can replace all forms of funding decisions, but there certainly are ways to join those up more efficiently. Thanks for that question.
And in the back, please.
Thank you very much for your talk and for your openness to discuss all of this. Being very open about it is perfect, in fact, for it, right? I really appreciate that you guys are already acknowledging that there will be bias in the algorithms and that you're planning to do things to change that. I was wondering if you could tell me how you might promote not only that you found bias, but how the community then decided to address it, and then any potential outcomes that were unexpected from that and changes that came from that, which might help all of us later as we continue to try to address this type of bias in algorithms.
Yeah, great question. And I think the key is to not design systems of implementation that insist that we will prevent bias from occurring, but in fact accept that bias will occur. It's inevitable that it will occur on dimensions we have not yet identified. And so the part of the implementation process is to have detection and mitigation efforts along the way. So that, we can talk about a variety of different potential concrete examples of that. But one would be to surface evidence of bias. So let's take the gender citation example, right? The algorithms reproduce this citation gap in gender and then apply different confidence scores based on that. One way to mitigate that bias is to identify that that's occurring. And because there will never be one single algorithm that rules them all, right? There's no one way that we're going to evaluate the credibility of research with a single score. Instead, if we embrace multiplicity of algorithms, then you can identify that specific bias is which algorithms are more and less susceptible to it. And that will provoke the algorithm makers to try to address the bias itself, but then also help the reader who's experiencing those to say, oh, okay, I see that bias occurring. I'm going to apply a correction to the ones where it's strong, and I don't need to for the ones where it's weak. And that may vary across the variety of things that people may identify as biases that they think are legitimate or illegitimate for making any assessments. So for us, the baseline is make it transparent and then promote responsible use. And responsible use is another 30 minutes of conversation. So I'm delighted to talk about that after. So thanks very much for the question.
Thank you.